Welcome back to Big Picture Statistics and Computer Analysis. Today we want to talk about the dependent samples t-test, also known as paired samples t-test and match samples t-test. So basically, in this test, we take a sample, we measure some parameter in the sample or statistic, and basically we measure it at one point, then we measure it at another point. So you could think of this as a before and after case. We take the difference between the two measurements, between each subject in the test. Then we take the average, d bar. Then what we do, we can proceed. We have a bunch of new formulas here. This formula, there's an alternate this way that you may find useful. Some of you may prefer, others you'll just use it in this form. And the degrees of freedom is the way it was for one sample t-test. It is n minus 1. The test statistic is obtained with this formula. And this is the mean for the differences d. And then we proceed as follows. We develop our null and alternative hypothesis as always. Get the level of significance alpha, degrees of freedom. We can determine the rejection region. And then we can calculate the test statistic using these first. And then we can reach our conclusion. So we want to just go straight to the SPSS. So we will overlook some of that, but we can compare it later with how they would proceed that way. So let's take a look at this example together. A shoe manufacturer claims that athletes can increase their vertical jump heights using the manufacturer's training shoes. The vertical jump heights of 8 randomly selected athletes are measured. After the athletes have used shoes for 8 months, their vertical jump heights are measured again. The vertical jump heights in inches for each athlete are shown in the table at alpha equals 0.10. Is there enough evidence to support the manufacturer's claim? Assume the vertical jump heights are normally distributed. So here's our data set. So we have 8 athletes, so N will be 8. And just take a look at this. We have their vertical jump before using the shoes, vertical jump after using the shoes. Now, here what we want to do, basically the claim is that their height should be higher after they use the shoes. So if their vertical jump height, if it's higher after they use the shoes, the average of these heights should be higher than these. Now, this mu sub d that they use in the null and alternative is really the difference between the two mu's of these two groups. So basically, the convention this book uses is the difference between the mu's. So is mu1 minus mu2. Mu1 is the vertical height before using the shoes. Mu2 is the vertical height after using the shoes. Now this can be reversed. If you have a book that reverses it, just take note of that. So for our purposes, we're doing before minus after. Now if we do before minus after and our claim is that they jump higher after they use the shoes. mu1 minus mu2 should be negative then, because mu2 is higher than mu1. So it would be the alternative hypothesis, that's the claim, because this implies that the difference is negative. The null hypothesis will be that the difference is greater than or equal to 0. Now with this, what we have the degrees of freedom. It's 7 because we do n minus 1. Alpha's 0.10. So let's go to our t-distribution. So here's our t-distribution, and just recall here, the alternative hypothesis is that the mu of the differences is less than 0. So since it's less than a value of 0, we're doing a left-tail test. So we're doing a left-tail test. Area in one tail is 0.10, and degrees of freedom was 7. So our critical value, according to this table, is 1.415. However, because we're doing a left test, we will take the negative of this. So it should actually be negative 1.415. Okay, now we can take a look. That's what they have, negative 1.415. And then they proceed to compute the test statistic. And they got this. They landed in the shaded region. So they will reject the null hypothesis. If they reject the null hypothesis, there is sufficient evidence to support the claim. So this is good for the shoe manufacturer. It supports that their training shoe helped the athletes jump higher. Now let's take a look at this in SPSS. So let me open SPSS for you. So let's enter the values in SPSS. So the vertical jumps before they use the special shoes, I will enter first in the first column here. And this is after they use the special shoe. Okay, so let's go to variable view. Both of these will be on scale level. This one we will call, we can call it jump 1. And this one we will call jump 2. How about that? You can call them before and after as well, if you choose to. All right, so let's go. We have our categories labeled, our groups labeled rather. So go to Analyze, we'll go to Compare Means, Paired Sample T-Test, and we enter them in place of variable 1 and variable 2 respectively. And let's just take a look at options. We're not interested in confidence interval. Alright, let's just get the test. Okay. So, there we have it. They calculated the descriptive statistics for us that are relevant. And let's take a look. This is the output table for the t-test, the paired samples t-test rather. And they got a test statistic of negative 2.333. This is going to bring us in the shaded region. So, because recall the critical value was negative 1.415. This is less than that, so it brings us in the critical region. And that means we will reject the null hypothesis. And if we reject the null hypothesis, what that means, just like they concluded, there will be enough evidence to support the manufacturer's claim at the 10% level of significance. Because recall once again, the claim was the alternative hypothesis. So this looks good for the manufacturer.